Hello and welcome to the fireproof balloon experiment. For today's experiment, we will need the following items: 2 regular rubber balloons, fire or a source of fire, water, and air. So what will we be observing today? In today's experiment, we will be observing what happens when you place a balloon filled with just air over fire and another balloon filled with air and water over fire. We will then explain why the balloon filled with water does not pop versus why the balloon only filled with air does. So 2 balloons, 2 explanations. So let us begin by introducing the concept of heat distribution and conduction. Water is not easily influenced by heat unless there are high amounts of it or temperatures of it. It may quickly absorb the heat, but that only prevents other objects, like the balloon, from absorbing the heat first or too intensely. So what happens is, when you have the balloon that's filled with water, and I'll show you what that looks like now, you have air, which is gas, and then water underneath. So what's happening is that the water is going to draw the heat to the water first, thus preventing the cracking and breaking of the actual rubber. And then as far as gases are concerned, or air, on the other hand, it cannot quickly draw heat away from the rubber, thus causing it to pop. So there's nothing inside this but gas and air. So what happens is the fire is not quickly drawn to that, it just has to penetrate before it can get there. So during our experiment, we will observe the first balloon filled with only air should pop as soon as the heat comes near it. We don't even actually have to put the heat onto it, it should just pop. And then the second balloon filled with air and water should not pop at all. While it may turn black with soot, the water should absorb the heat first and prevent the rubber from breaking or becoming hot and weak. Okay, now let us begin our experiment. Of course, if we have any adverse results, we will postulate as to why this experiment did not work. Okay, so we're going to do this one first, and it is going to pop, I think. So we'll just take this pretty slow. So we're going to put, yep, woo! That was crazy. So obviously I didn't even touch the bottom with the heat, it just caused it to pop immediately because that gas draws the air, or the gas draws the heat quickly to it, so it did explode everywhere. So that was normal, that was exactly what we were looking for, which was great. So the next one, and the ratio is pretty different here too, so I did probably 1/5 of the entire balloon just by eyeballing it of water, and then the rest with air, because I wanted to be able to actually see the experiment. Obviously, if we did it with all water, it still wouldn't pop either, but I did want you guys to be able to see exactly what's going on here. So now, we're going to light it again, and we're going to see what happens. So of course now, I'm going to stop there for a second. As soon as we put the heat underneath of the other balloon, it just drew the heat right to it. It was fine. It didn't prevent it from breaking. So this one, I can get close to it, it's not going to break, and I can even hold it under the flame. And of course it is creating that darker black soot that I was saying. I'm even going to try it on the side, and it still won't. So wherever that water is, it's not going to pop. Now if I were to take it to the side, there's nothing preventing it on the side from popping, so it would definitely explode. So I'm glad that that worked. That's really, really cool. So what happened during that experiment, what we observed, was that, again, that water was drawing the heat first before, before the air could get to it. So I hope you enjoyed this experiment. Thank you.